The title of our lesson tonight is Draw a Picture and Write an Equation. So we're going to be reading a story problem or word problem, however you want to call it, whatever you want to call it. And then we're going to draw a picture and write an equation from that. So we have the problem: Marie and her mother hiked the trails, the Ansel Trail, the Briar Trail, and the River Trail. How far did they walk in all? And you can see by the signpost it says the Ansel Trail was 7/8 mile long, the Briar Trail was 3/8 mile long, and the River Trail was 5/8 mile long. On this one, we are going to draw our picture, which you can see down at the bottom. I have made a whole line, which I am going to go over again in another color just so that you can see this is our total right here. That means how many miles in all. So since we have the words in all, that means we want to add. Well, we want to make sure we have our pieces drawn. So you can see that I have divided it up into 3 pieces and made my 7/8 piece the largest, then my 3/8, and then my 5/8. So there's my picture. Again, the top line means how many in all, and then our boxes represent the numbers in the equation. On this one, you can see that I have, again, reproduced my drawing, and I think this time my fractional pieces are a little bit better, more representative in that the 7/8 is the largest, 5/8 is a little bit bigger, and then the 3/8 is the smallest. You'll also notice that I've written the dividing line 2 different ways. On one I've made it straight, and the others I've made it diagonal, and I've done that just to show you you can make it either way so long as it's evident to you which one is the numerator is on top. So my equation, since it says in all, this lovely word right here, those 2 words, in all, and I have 3 different numbers, means I must add, not multiply. I would do multiplication if I had 3 numbers that were exactly the same. But because I have 3 that are different numbers, then I'm going to add. And in this case, they're all fractions. So I have lined them up. 7/8 plus 3/8 plus 5/8 equals something eighths. Remember that when we are adding fractions, we are not adding the denominator. We're not changing the size of our fraction. It's still the eighths, but we are totaling them. So 7 and 3 is a 10, plus 5 more is 15. 15/8 is an improper fraction, so we need to then make that a mixed number. We'll do that on the next slide. Okay, our improper fraction was 15/8. We need to make that a mixed number, and we do that by one of 2 ways. We can put the numerator inside a division box, and our denominator becomes our divisor, and we want to know how many groups of 8 we can get out of 15, and that answer is 1. That makes our whole number. We have 1 whole group of 8 out of 15. We multiply 1 times 8 equals 8. We subtract that from 15, and we have 7 left over. Our remainder becomes our new numerator. We have 7/8 left. So our new mixed number is 1 whole and 7/8. Remember to make your whole number larger than your fraction. Another way to do this, in case you would rather subtract than divide, you can subtract 8/8, because that is a whole, right? If we took a whole piece and we divided it into 8 pieces, 8/8 would create that 1 whole mile. So I'm going to circle that and put a 1 over it, so that just helps me recognize that I have a 1 whole. Then I put my equal sign, and 15 minus 8 is 7. Bring over my denominator of 8, and now I have that number of 1 and 7 7/8. You have to bring this one hole over and put it with your 7/8. So you have 1 and 7/8. Either way, whichever way you like to solve it is fine with me. So we'll be talking about that tomorrow in class. We'll be practicing reading problems and then drawing a picture, and from that picture we will then be writing equations from that. Have a nice night.